Okay, so this integral right here proved to be decently challenging for most calculus students, and challenging for me as well. Okay, so what's the trick here? The trick is, first let's start with the substitution, and you can see that we can make a substitution here with the x squared, and that might just make things a little bit easier. It's not going to make everything completely easy, but it'll make things a little bit easier. Okay. So let u equal x squared, and you'd see that du is equal to 2x dx. And we also got to change our bounds. So we were originally x, now we're going to u. So what was x? 4 and 2 squared root of 2. Okay, so 4 squared is 16, and 2 root 2 squared is 4 times 2, which is 8. Okay. So our new integral will be right here. It'll be 16 to 8, and it'll be u plus 8x and u minus 4. Now dx, what is dx? Well, dx itself, dx is equal to du over 2x. So we see we got du over 2x. Note that we have x times x here. So x times x turns into x squared, which turns into u. So this turns into 16, 8, u, right? X times x is x squared, which is u. So we have u minus 4, u plus 8, du. My bad, I don't know. You guys can see all that. There we go. Du. And, right? My bad. Don't make that mistake again. But not let you guys see it. Okay, so substitution made it to this integral. And that integral isn't that useful completely. Right? Okay. So what can we do with that? So we see that we have u plus 8. I'm going to write here in green with the other integral again. So 1/2 16 8 u plus 8 u square root u minus 4. Now, this isn't too friendly yet. Can we make it friendlier? Yes, we can. Okay, so what can we do? Well, maybe something with that, right? Or more specifically, maybe something with this, right? Okay, so maybe we let's pick a different variable. Let's let a is equal to square root u minus 4. Okay. Let's just do something, get rid of the square root, right? So a squared is equal to u minus 4. And now we can implicitly differentiate, so we get a 2a dA is equal to what? du. Okay. So the reason why I did that is just, I think it's easier to differentiate this way so that you can see that. Okay. So 2a dA is equal to du. Note, so we can replace the square root with a and the u, right? We can write our u's. We can solve for u. We said u is equal to what? A squared plus 4. Okay. So let's write all that stuff down. So, and also we have to change our bounds. So we were originally in u, going to a. U was originally 16 and 8. So if we go into a, right? So 16 goes in here. 16 minus 4 is 12. Square root 12. We'll just write it as square root 12. Yes, you can rewrite it as something else. Put a in here. 8 minus 4 is 4. Square root 4 is. So our new integral is square root 12. 2. And I'm gonna leave the u like that for now. U and this a, and the top right? Okay, so u plus 8. What can I do with that? Actually, nothing's wrong, but we could make it easier. Okay. We will do a substitution like that later, and nothing was wrong though I did. In fact, you would still get the answer, but I see a trick here that we could make it a lot easier. Factor out 1/2, and then we could write this as 16 to 8. And note that this is, look at this. This is the numerator. So since it's the numerator, you can write it as u minus 4 du plus 16, 8. Right? You can use the linearity of the integral, and now, oh, look at that, that's a lot nicer. It's a lot easier too. Okay, so you see that, and yes, those can go away. This one is just like that. Okay, so this is a little bit of an easier integral to do now, and that's nice and everything like that, but it's not perfect, okay? So now we have two integrals to solve. This one is going to be a lot easier. This one's not going to be as easy. Okay, so I'll go purple. I'll do this guy in purple, okay? So, and yes, I'm just leaving the 1/2 out here for now. So, okay, 16 over 8, and 16 to 8, and it's du over square root u minus 4. And you could just do a substitution here just to, get rid of this u minus 4, but that's not really needed. We could see that, like, that wouldn't lead to anywhere specifically, but we can do it anyway just to make it a little bit easier mentally to see instead of jumping the gun here. So now I'm going to let a equal u minus 4, then dA is equal to du, and this just allows me to change my bounds a little bit and make it even easier. Okay, so going from u to a, 16 and 8. Okay, 16 minus 4 is 12, 8 minus 4 is 4. Okay, so now I got this new integral, which is from 12 to 4 square root a dA. And yes, now as you can see, look at this, this is super easy. And this will be a to the, okay, so negative 1/2, right? Plus 1/2. Plus 1 is positive 1/2 divided by 1/2. 12, 4. And in other words, this is 2 square root a 12 to 4, which is 2 root 12 minus 2 root 4, which, there we go. 2 root 12 minus 2 root 4. And what is that? That is what? I'm just going to leave that as 2 root 12. This one, I can just write it as 4. Okay, so that's a little bit nicer, right? Okay, let's do this other integral, and I'll do this one in green. Okay, move my chair, sit down. Okay. This other integral, 16 to 8, 8 u minus 4. Okay, so this one, what do we see here? Okay, now we need to start doing something a little bit fancy, right? So I'm going to call it b, let b equal u square root u minus 4, and we could let b squared, just following this, right, we could see that at b u minus 4. Okay, so what's the implicit differentiation here? Right, it would be 2b db is equal to du. And we are also changing our bounds here. Okay, so we're going from what? What is that? that is from u to b. Putting 16 into here, 16 minus 4, what is that? Well, 16 minus 4 is 12, square root 12, okay. 16 and 8, square root 12. Putting 8 into here, 8 minus 4 is 4, square root 4 is 2. So this new integral, okay. Square root 12 and 2, right? And then we have u, and this guy is now b, and there's an 8 here still, and du turned into 2b, db. Yes, the b's can, oh, my bad. u, b, yes, the b's can go away. Okay, so now we're left with this integral, which is square root 12, 2, and look, it's u. Well, what is u? Okay, well, u itself, in this case, is what? It's b squared plus 4. So don't make the mistake of getting rid of everything. And by the way, this is 8 times 2, 16. Just trying to make this a little bit nicer here. So db over b squared plus 4. Okay, look, there's a u here, right? Because we couldn't get rid of it initially with our substitution, but we know that you can rewrite u as this. So remember, u is not a constant, it is a function of b, and this is an integration of b. Okay. So now what we have is 16, and look at that, that's b squared plus 4, that's an arctangent integral. So we get tan inverse, and it's 16 over 2, because that's just how this integral works, right? Remember the formula for your tangent integrals, your arctangent integrals, right? And then this turns into what? b over 2, evaluated from square root 12 to 2. Okay, so this is 8 tan inverse. Now square root 12, right up here, square root 12, if you guys don't know. My bad, I'll write it right here. Square root 12 is 4 times 3, which is 2 square root 3. Okay, just so everyone knows. I'm sure everyone does. So when I put it into here, this just becomes square root 3 minus tan inverse of 1 eventually. Not eventually, it will become. Not just because, remember, there's a 2 in here, right? This arctangent is a 2 here. That's just the formula for the integration of arc, for this, you know, your typical arctangent integral, right? That's how it turns out to be. And this is tan inverse. So this is equal to 8. Now, tan inverse of 3, believe that, okay, let's draw a unit circle if we're confused. Okay. So, where is, should be right here. Let's test pi over 6, right? Actually, I think it's going to be pi over 3. Tangent of pi over 3, what is that? That is equal to square root 3 over 2 divided by 1/2, which is equal to square root 3. Yes, okay. So we know that tan inverse of square root 3 is equal to pi over 3. And then minus, what's tan inverse of 1? I believe that is, so if we draw it again, so what is some angle equal to 1? Okay, if we're to test, right, it's tangent of 2 pi. What is tangent of 2 pi? It is 0 over 1, which is 0, so that's not true. So what is an angle where it is? Okay, it's 45 degrees. In other words, it's pi over 4. So tangent inverse of 1 is equal to pi over 4. So we have, what do we have here, right? We have pi over 3 minus pi over 4, which is what? That's pi over 12. 8 times pi over 12, that is 2 pi over 3. Okay. So where is our, we're almost finished here, right? We have this guy's answer, and we have this guy's answer. But remember we had a 1/2 right there. Yeah, 1/2 right there on the outside of this. Oh, okay. So I circled both of my little mini answers in red, and now I just have to combine them together. So in other words, we have 1/2. And these are addition, so we had 2 square root 12 minus 4. 2 square root 12 minus 4 plus 2 pi over 3. Okay. As you can see, there's 2's in here, so that can go away. And then this 4 can turn into a 2, and this 2 can go away. Okay. So I don't have any more space, and this is unfortunate. So I'm going to go to the whiteboard now. Okay. And I'll recap real quick. We have 1/2, and it was 2 square root 12. Need a better marker. 2 square root 12 minus what? Minus 4 plus 2 pi over 3. Right, that was our original answer, and now we set that to be square root 12 minus 2 plus pi over 3. And what was that guy? That was 2 square root 3 minus 2 plus pi over 3. So this is your final answer. And unfortunately, these markers are so dog shit here. All right. Oh my god. There's like no ink in these things. I wonder if you guys can see that. Yeah. There you guys go. That's your answer. Nice little compact answer after all that. There we go. I'll zoom out. There we go.